everybody. Well, today we're going to begin with our review practice for MCA Math 8th grade 2016. So, I'm gonna use this Math Cornell video notes for you. Everybody will be free to have a packet of that from the classroom. Also, every one of you will receive individual folder with all practice worksheets and all the information you need in order to be successful in MCA. Part of the folder also is your formula sheet, the one that will be provided for you on the test, which means every formula that you see on this piece of paper will be there for you and you don't have to remember. But there will be some very important things that I would like you to write down on this piece of paper, and I will show you that in class. We will discuss that. But any important notes that you think you may forget, but it's nice to have it written around the formula, for example, reminding some specific variables, what they mean, or maybe definitions, that will be a great thing. Just like small cheat sheet, some people call it, and you can definitely use that. So, first lesson or first learning target that we're gonna discuss will be I can use scientific notation. Scientific notation will be the first one, and a lot of you remember that we already started, we did some practice, and you do have completed those worksheets, which is great. And I don't want you to spend a lot of time on it because we gotta move on and make sure we cover as many as we can topics and ask as many as we can questions. So for this one, maybe just quick review of the video and take a look of the worksheet, and if you have additional questions, let me know. Otherwise, you can move on to the next one. The organization of each video will include practice assignment on the left, so you will know which worksheet goes with this video. It's gonna say day 1, 2, 3, or whatever number is. And also on the top over here, I will have this highlight main information that you need in order to complete the problems, or you may need to write it down and try to memorize and later and get ready for the test. So the definition of scientific notation stays for a number that could be written in this form. So we have some number c, which is integer, positive or negative, times 10 to another number. First thing what you need to know about c. Well, c has to be between 1 and 10. So c gotta be greater than 1 but less than 10. For example, c could be 1.1 or 9.9, but can be less than 1 or exceed 10 or even 10. So 9.99999 will be the last number that you can use for c. Another important thing is scientific notation. When we multiply by a power, the base of this power is always 10. And then we have certain amount of number, integer here, positive or negative, that will describe what the number looks like. And for example, if we have written numbers in standard form, 325,000 in standard form, and we want to convert this number to scientific notation, then we're going to put this decimal point dot on the end, and we'll start moving the dot 1, 2, 3, 4, 5 times until we reach the first number of the standard form. And we're going to write 3.25, so notice this number 3.25 is between 1 and 10, and then times 10, always base 10, to the power of 5. Why is power of 5? Because we move the decimal point 5 times. Then we have another standard form, 0.005 here. This is a small number. The decimal point is given for us. So we're going to move 1, 2, 3, 4 times, and your goal is to pass the first number. So you always pass the first number, and then you write that number here. 5 times 10 to the negative 4, it moves 4 times the decimal point. Now, another question, why this one is positive and this one is negative? Well, something that we also discussed earlier was if we have numbers with positive exponents, they represent big numbers. So always try to remember those big numbers that we're dealing with. In order to write in scientific notation, their power or exponent is always positive. But the small numbers, very small numbers, they will always represent negative exponent. So one of the good strategies here, I would say those two things are really important to be written down. They will help you to remember. And when you have given multiple choice questions, be careful with what the standard form is given, if it's given for you, and how you gotta convert it to a scientific, or opposite way. If it's given in scientific notation already, then based on the power you will decide if this will be a large number or small number. So those are kind of the basic keys that you need to use. Let's take a look of example number 1. Example number 1 says multiplying numbers in scientific notations. We have given the product of two scientific notation forms and then 4 multiple choice questions answers. You gotta find out, when you multiply all those things, which one of those 4 answers will be the right answer. First strategy, look at the numbers and think about which one of those 4 is not in scientific notation. One of the rules says that the first number needs to be between 1 and 10. Which one is not? The only one that is not is C. So you can exclude C right away from your answer. Now you gotta deal with 3 answers. And another new thing will be, before we start actually multiplying, I want to introduce you to a graphing calculator. So the graphing calculator will be your tool that you're going to practice with during the whole MCA review, because this will be the model of calculator that you will be allowed to use on the test. There will be certain problems that you would not be able to use the calculator, and if it's not there for you, then you gotta do your best using mental math or some strategies in order to answer correctly. And if the calculator is given for you, then you have to know how to use it again to get your right answer. So we're going to start with this graphing calculator, and what we're going to do here, the question is, what will be the answer if we multiply those two scientific notations? Well, first thing, we're gonna turn on the calculator and I'm gonna show you some of the functions in class. So right now what I'm gonna do, I will start multiplying all those numbers together. So I'm gonna type 6.1 times 10, and this button over here, similar to scientific calculators, shows the power. So I'm gonna click over here, and that will be to the power of negative 9 times. Next one is 2.3 times, and we have 10 to the power of 3. So times 10 to the power of positive 3. This whole thing is giving me 1.403 e mean exponent 10 base to the negative 5th. So let's take a look of C. Which one of those 4 answers has 1.403 times 10 to the negative 5th? Well, everybody will agree that this is choice A, and that will be our answer here. Awesome. Let's take a look at another example. Number 2. And please, if I'm going fast, you know what to do. Pause the video and hold on. Re-watch the video if you need to, or just take your time to write down the information you need as well. So with the next example, we have given division of two scientific notation. First one was product, we had to multiply. Now we're going to divide those. And before we begin with that, please again look at those 4 answers and tell me which one we can exclude. So which one of those four numbers up front is between 1 is not between 1 and 10, and that will be only choice B. So we can cancel this and think about what will be one of my answers. So let's go ahead and do this division. Now I'm going to use the parentheses. It's very important when you divide fractions or product divided by another product, make sure you use the parentheses. This will give you more accurate answers. Otherwise, sometimes it may not go so well. So what I'm doing, I'm using the parentheses here, and I'm going to use the parentheses over here. So inside the parentheses, 1.728 times 10 to the power of 6, close the parentheses. So this is what I'm typing. Then I will click division sign on the calculator. This is because the fraction line means division, right? This is the same as dividing. Division sign. Open new parenthesis for the bottom product and type 5.4 times 10 to the power of 8 and close it. This will be equal to, now here's what we get. We get answer 0.0032. Not always the calculator will give you the exponential form, and most of the time if we have only a couple numbers before the point, the decimal point, or after the decimal point, it means we need to figure out what will be the scientific notation. But that won't be a problem because we already discussed that when you have given example like this, you gotta move your decimal point until you reach the very first number and past the first one. So that will be 1, 2, 3 times. Okay, so we're looking for answer 3.2. We move 3 times the decimal. It's a small number, so will be negative. 3.2 times 10 to the negative 3. So absolutely C answer will be the right choice for this one. Alright, and the last example that I want to share with you about scientific numbers. Sometimes you may have given this 4 different options, and you have to decide which one of those 4 shows you that numbers are in order from least to greatest. From least to greatest. Alright, so for that reason, let's convert each one of those numbers to standard form, because I think when you see the numbers in standard form, you will have better idea of what it's gonna look like from least to greatest number. So I'm gonna draw a line and start with A, B, C, and D. First one, 3.5 times 10 to the negative 2. Since it's negative power, we're moving the decimal point 2 times to the left in order to get a small one. So this will be 0.035. Next one, we're moving 1, 2, 3 times. So that will be 0.0035. And the last one here, again we're moving 3 times, 1, 2, 3 times, so 2 zeros up front will be 0.0053. Now, this is one way if you are not offered calculator and you gotta do it by hand. But let's say you can use the calculator here. If you can use the calculator, then just go ahead and type the numbers and you will see what the decimal or standard form is gonna look like. So for the B answer, we're gonna have 3.5 times 10 to the power of negative 3, which is 0.035. Then we have 3.5 times 10 to the power of negative 2, which is 0.035. Next one will be 5.3 times 10 to the power of negative 3, which is 0.053. Then next one will be 3.5 times 10 to the power of negative 3, 0.035. Next is 5.3 times 10 to the power of negative 3, again This is 0.053, and 3.5 times 10 to the power of negative 2, and this will be 0.035. I'm looking that this is to the negative 2, so this one it looks like I missed one zero here. Okay, so we can just double check this one. 3.5 times 10 to the power of negative 3. Yes, so we have two zeros after the decimal point. Okay, and the last one, 5.3 times 10 to the power of negative 3 will be 0.0053, then 3.5 times 10 to the power of negative 3, 0.035, and final one will be 3.5 times 10 to the power of negative 2, which is 0.35. Alright, so let's take a look at those numbers. First thing, we know that the smaller number will be the one that has the most zeros up front, right? Because no matter, if we have 5, 9, 8, 7, if the number has 2 zeros or 3 zeros up front compared to other numbers, then that will be the smallest one. Well, if you check all of those and the order is least to greatest, and you take a look of all those numbers, which one shows you the least? Well, you will say maybe those two, but this one is smaller. But let's check next one. Now those two have the same zeros, but 53 is larger number than 35. So the conclusion will be that D will be the right choice here. D is showing you all the numbers from least to greatest, and the rest of it are not in the right order. Okay, so this is just a quick review again, and if you have more questions, we'll discuss in class. Thank you for watching the first video.